Okay. So there are two kinds of differential equations. Okay. First one is called ordinary differential equation. And second one called partial differential equation. Okay. So in short it is called ODEs, and this is called PDs. Okay. So first we will talk about ODs. Okay. So let's take one example. What is called ODs? So why it is called ODs? Because the derivative is only with respect to single dependent variable. Okay, so in this case dependent variable is what? Y. So in ODs you will only see either dy by dx, d2y by dx square, dy by dx raised to the power 2, which means that only you will see the kind of functions, equations like this: dy by dx, d raised to the power dy by dx square, something. Okay, but you will not see something like f of dy by dx comma d. Suppose it is a first in dependent variable, you will not see this kind of function. Okay, you will only see this kind of function, so that is called OD. Okay, and in the case of PD you will see partial differential, since you know that in partial differential equation there are more than one dependent variable. Okay, so that is why those kind of differential equation is called partial differential equation. Okay, but in our module, in this module we will talk about ordinary differential equation. Okay. Okay, so first moving in that direction, let's talk about order. What is called order of differential equation? Okay, suppose you have the same differential equation whatever I wrote earlier, that is d2y by dx square plus dy by dx equal to x square y square, and in other words you can also write it like this. Okay, sometimes I will write like this and sometimes I will write like this, so you don't have to confuse here. Okay, so yeah, so if someone asks what is order of this differential equation, okay, so the order of differential equations defines the highest degree derivative. Degree derivative, that is called the order of differential equation. Okay, so can someone tell me what is the highest degree of derivative in this differential equation? Can someone tell me?
2.
2, which means that the order, you can see that in this derivative it has second degree derivative. Okay, so that's why the order is 2. Okay, now let's talk about what is the degree of differential equation. These two are different thing. Okay, so degree of differential equation. Okay, so in this case it says the degree of highest highest order derivative. Actually I have to write order actually here the highest order derivative. Okay, there is a difference between order and degree, because this is a order, this is not a degree is, which means that the power. Okay, so that's why here you can see that the 2 is not the power of this differential equation, it is actually the order of derivative. So that's why this word is important. Okay, so it should be order. But in the case of degree, the degree of differential equation says the degree of the highest order derivative when when all derivatives are free of fractional powers. Okay, so it says that if suppose in some differential equation where some order of derivative is the highest in that differential equation, then the degree of that order of derivative will be called as degree of differential equation. So in this case you can see that this term is actually the highest order of derivative, and you can also see that its power, the power of this derivative is actually 1. So that's why in this case if someone asks what is the degree of this differential equation, then the answer will be 1. Okay, so now let's take another example. If someone asks what will be the can someone tell me what will be the order of the differential equation and what is the degree of differential equation? What will be the order of this differential equation? Tell me.
2. Order will be 2.
Order will be
2.
2. Okay. What is the degree?
1.
1. Okay. So here you can see that your answer should not be 2 in the case of degree, because here you can see that actually the degree of the differential equation, it seems like the highest degree is 2, but the answer is 1, because first we have to look this, what is the highest order of the derivative, and the power of the highest order derivative will be equal to what? Degree. Okay, so in this case the degree will be 1, not 2. Fine. Okay, so let's take another example. Suppose you have a differential equation like this. Okay, so tell me what is the order and what is the degree? Tell me quickly.
Order is 2.
Order is 2. Great. What is the degree?
1.
No, that is not
Degree
correct.
2.
Huh?
Degree 2.
Degree will be 2. Because in the definition of the degree, you have to be very careful. It is says that are free of fractional powers, which means that you have to remove all those fractional powers. Then you have to decide what is the degree. So here in this case you can see that there is a square root, which means that first you have to make it free from fractional powers. Then you have to do what? You have to square it, okay? Or you can do something like this. Just move in this side. So you will see. Okay, now square it. When you square it, you will see something like this. Okay, plus first order derivative. I mean, you can also write minus 2kx d2y by dx square equal to dy by dx square minus 1. So you can clearly see that now the degree is what? 2. So 2 is the answer, not 1. Okay. Now you have one question in your mind. I know that. Suppose if someone wants to square it here only, then the power of this will be removed. But when you do 2ab, then another square root will come into the picture. Then you have to square it again, but that is not the way. You have to make it you have to remove the fractional powers such that the degree will be minimum. Okay, so the efficient way to remove the fractional power is this. In that way, that you can also do that, but the power will be 2 more. Okay, but you can also see that that is not efficient way. So in this way you have to do it. Okay, so degrees should be minimum, not maximum. Okay, fine or not?
Yes.
Yeah. Okay, so let's do one more problem and tell me what will be the degree. Suppose we have a differential equation is like this. Okay, so tell me what is the order and what is the degree. It's an infinite series.
Sir, order 1.
Order 1. Degree?
Will be infinite.
Infinite. No.
Degree can't be different, sir.
Degree will also be 1. Because you can see that this whole expression is nothing but y equal to e raised to the power dy by dx. It is nothing but the exponential series. It's fine or not? Okay, so
Yes.
it is clear that the degree is also 1 and order is also 1. Now I know that one thing come into your mind, that why the degree is not infinity. The reason behind this is when the power is increasing, then the denominator term is also increasing, which means that this series is actually converging. Okay, this series will actually converge after some times. So which means that the effect of this power will actually be negligible. One thing you should understand, that for every function you cannot find the Taylor expansion series, Maclaurin series. That series should be converging. Okay, you cannot find any kind of Taylor series and Maclaurin series for every function. Okay, so here you can see that this series is actually converging, so that's why you are writing like this. That's why the order is 1 and degree is also 1. Fine. Okay, one important point is solution. Solution of nth order, nth order of differential equation will contain n independent independent arbitrary constants. Okay, which means that whenever you see there are n independent arbitrary constants, then it is sure that that differential equation is actually nth order. Okay, for example, suppose you have a family of graph or equation, you can say. Okay, suppose you have this function. Now someone wants to you to solve, to you to find the differential equation of this equation. Find the differential equation of the equation. Then first step, you need to find the number of constants, number of arbitrary constants. Which is what? 2. Okay. Then find derivative, or you can see that, you can say also say that, yeah, find derivatives of equation as the same number of arbitrary constants. Then the third step is what? Eliminate constants. Okay, so in this case you can see that there are two arbitrary constants which are C1 and C2. Then first step is done. Now the second step is you have to find the derivative. Okay, and you have to find 2 times derivative, because arbitrary constants are 2, which means that you have to find first derivative of the equation and second derivative of the equation. Then you have to eliminate these constants. Okay, so yeah, the given equation is what you can also write is like this: c1 e raised to the power 2x plus c2 e raised to the power 3x plus x square minus y equal to 0. This is the first equation. Now you have to differentiate it. So you will get 2c1 e raised to the power 2x plus 3c2 e raised to the power 3x plus 2x minus y dash equal to 0. This is the second equation. Now you have to find the derivative one more time, because you have to find 2 times the derivative. Okay, now differentiate this again. So you will get 4c1 e raised to the power 2x plus 9c2 e raised to the power 3x plus 2 minus y dash, 2 minus y double dash equal to 0. So here you can see that you have first equation is keep as it is. Okay, because after solving for c1 and c2 from these any two equations, Then you have to substitute C1 and C2 in the third equation. Then the got equation or the got equation will be what? Differential equation. So you can find C1 and C2 from any two of these three equations. So what will I do is I have one shortcut. So you can see that this is nothing but in a very efficient manner. I have arranged this equation in a very efficient manner. Then what will I do is I will just write in the form of determinants, and that is what? So you can see that the constant C1 is nothing but the e raised to the power 2x, the constant C2 is e raised to the power 3x plus x square minus y. This is what? 2. This is what? Yeah, this is 2 e raised to the power 2 raised to the power 2x. This is 3 e raised to the power 3x. This is 2x minus y dash, and this will be 4 e raised to the power 2x. This will be 9 e raised to the power 3x, and this will be what? 2 minus y double dash. Okay, so you can see that you have eliminated C1 and C2, and after solving this determinant, the result will be what? Your differential equation. So you can see that this whole column has e raised to the power 2x. Then you can take it as outside from the property of determinant, which I have already taught you. And in the second column has what? E raised to the power 3x. Then you can also take this as a common. So the remaining will be 1, 2, 4. This will be 1, 3, 9. And there is no such common, or if there is no such factor, then you have to leave it as it is. So it will be 2x minus y dash, it will be 2 minus y double dash equal to 0. Okay, so this is not equal to 0, which means that this is arbitrary, so you don't have to solve it. Now the remaining is what? This determinant. Then you have to find the determinant. That will be what? 6 minus y double dash minus 18x plus 9y dash minus 1, 4 minus 2y double dash minus 8x plus 4y dash plus x square minus y 18 minus 12 equal to 0. Okay, so take,
Sir,
yeah, tell me.
in the first, no, the solving the matrix determinant,
Yeah,
the term would be 6y double dash.
6, yeah, 6y double dash. No, why 6y double dash?
So 3y double dash.
No, if you multiply this, then it will be 6 minus 3y double dash. Yeah, thanks. Minus 3y double dash. Okay, so this will be, is everything correct after this? Minus yeah, minus 18x plus 9y dash, this will be 4 minus 2y double dash minus 8x plus 4y dash, else is correct, right? So yeah, so minus y double dash, then you have to find the factor of y dash, here 9y dash, here minus 4, then you will have 5y dash. Now you have to find y. Okay, so here you can see it is minus 18y and it is 4y dash, so that will be minus 18y plus, there is no such y, right? Only one 4y, minus 4y, minus 18y and minus 4, no, that is also not, there is no y, right, after this. Yeah, now you have x minus 18x plus 8x, okay, plus x square. Now you have how many constants? Plus 6 minus 4 equal to 0. So yeah, minus y double dash plus 5y dash minus 18y, and this will be 10x then x square plus 2 equal to 0. So this is the resulting differential equation. Is it correct or not? Tell me. The thing is, are you getting it or not? It's a very easy, right? Fine?
Yes, sir.
Yeah. Should I move forward? Okay. So let's move to the definition of linear and non-linear differential equation. Okay. So yeah. To understand that, first what will I do is I will consider some operator, okay? And what are those? I will consider d by dx as capital D. Similarly, d2 dx square as d square and so on. Okay. Now, from the definition, if you are able to write, if we are able to write dE in the form of Ly equal to what? Ly equal to what? Do you know that? Tell me. Ly equal to what? B. Okay. Where L is actually a function of a1x, a2x and so on, and also d, d square, dq and so on. Okay. And b is actually a function of x only. If you are able to write any differential equation in this form, then that kind of form of differential equation will be called as what? Linear. Okay. Then it is called linear ODEs. Okay. Otherwise non-linear. Okay. For example, suppose you have some kind of differential equation like this. Okay, tell me, is it a linear differential equation or non-linear?
Non-linear.
Non-linear. Why? It's a linear, no? You can see that I can write this differential equation as this: x square d square y, okay, minus x dy plus y equal to e raised to the power x. Okay. Now you can see that I can write x square d square minus x d plus 1 y equal to e raised to the power x. Then this is what? This is L. Okay. So it is clear that it is in the form of Ly equal to b, and b is what? E raised to the power x, which is a function of x. So you can see that this L is actually a function of x and d square. I mean x and that operator d. Okay, not a function of y. So that's why this differential equation is called what? Linear ODEs. Okay. Now take another example. Suppose, yeah, example number 2, x square d square y dx square, okay, minus e raised to the power x dy by dx plus y square equal to ln x. Is it linear? Is it linear or not?
Not linear. So because y square term is there.
Yes, it is not linear. Okay, and there is one more thing you have to understand, that there is no such multiplication here. Okay, here there is no multiplication between L and Y. Okay, what is it then? Hmm? There is no such multiplication here. Here actually L is a kind of operator. L is a kind of operator which is acting on Y. Okay, it is same as sin x. Okay, sin is a operator which is acting on x. Okay, so you have to understand that this is not a multiplication. Otherwise, that's why you are, or that's why this function is actually what? Non-linear. Okay, okay, let's take another example. I know that you will be in trouble in this case. What is this, linear or non-linear?
Linear.
Linear. Okay, fine. Okay, so you have to understand that if you are able to convert this into ly, then maybe you are thinking like, no, this is, there is an extra term that cannot be taken as a y outside. Okay, but the thing is it can be moved here. Okay, so that it can be written as this. So that's why this is ly equal to b. So what? Linear. Fine. Now you can easily identify, right, which equation is linear and non-linear. Tell me. Fine or not?
Yes.
Yeah. So sometimes, in GATE exam, those people can ask in one number question, 1 marks question. Okay. So yeah, it's a very fundamental, but many times people can solve it as a wrong. Okay. So yeah, let's take a problem. Form the equation into differential equation. Okay, and the equation is y square equal to 4a x plus b. Do this quickly. What will be the differential equation? This is equation of which curve? Can someone tell me? This is what? This equation is what? Of which curve? This equation?
Parabola.
Yeah, parabola. Okay. Now after getting the differential equation, you will be able to see that that particular kind of differential equation will actually represent the family of parabola. After getting the differential equation out of this equation, then you will get to know that what is the differential equation which can represent as a
But
parabola, family of parabola. Are you solving it or not? If you're not solving, then tell me, just don't waste my time, okay? Okay. How many constants are there? Hmm? Number of constants equal to what?
um,
1. There are two, no? A and B, both are constants. Okay? Which means that you have to differentiate this equation twice. Okay? Then you can eliminate both constants. Otherwise, you cannot. Okay? So, clearly, now differentiate this first time. It will be 2y dash equal to 4a, and that will be constant, that will become 0, still another constant. Now differentiate it once again, so you will get 2y double dash plus 2y dash square equal to 0. That's it. So you have y double dash equal to minus y dash square. So this is the differential equation which actually represent a family of parabola. Why it is called family of parabola? Why it is called family of parabola? Because after solving this differential equation, you will get this. And you can see that this a and b are actually arbitrary constants, which means that if you change the value of a and b, you will get different parabola. That's why it is called what? Family of parabola. Fine? Okay.
yes, sir.
Yeah. Okay, so yeah. Let's move towards some model. Yeah, tell me.
So, do we actually call the differential equation as family, or do we call the solution of the differential equation as family?
Yes, the thing is actually when after solving this, you will get this, right? So, using some boundary conditions, suppose you have a boundary condition like at to x equal to this, y equal to this, then you are able to get one constants. Now you have another boundary condition, okay, like y equal to x equal to 2 equal to y equal to something. Then you can eliminate another boundary another arbitrary constant. So which means that you need two boundary conditions to get the particular solution. Okay, this is actually a boundary value problem. Okay, which means that you need two boundary conditions to get a particular solution. This is not a particular solution, this is general solution, because it has two constants a and b, and after imposing boundary conditions you can get a and b. Then if you substitute a and b into this equation, you will get a particular solution, which means that that is only one solution, or you can also say that that is a unique solution. Fine. But right now it is a family. Fine or not?
So,
Yeah.
yes, sir. So, and also the for if the dy by dx has a power, then can we call it a linear?
This one, this is not
Now here,
linear.
I mean, here the y dash has a power, isn't it? So, if any in any equation, if y dash has power, then can we call it as non-linear?
Yes, definitely.
So, also, if there is any product between y dash and y, then also we can call just non-linear.
Yes. The thing is, this is, I mean, if you are able to write like this, then that is linear, okay? Then you can also see that if you have some term like y square, y cube, y dash y, something like that, which means that it is clear that that is not linear, okay? So you are talking about the same thing, okay? The thing is, in L, there should be no such y. In L, there should be no such y, otherwise that equation will be non-linear. It is clear that in L, it should contain either d or function x, otherwise you cannot write it. Fine.
Okay, sir. So if the any function is coming inside the logarithm or trigonometry, then can we find out the degree of that differential? I mean, if y dash is coming inside a logarithm or sin x, can we find out the degree?
Yes,
And
yes, you can also get it, no? The same thing, whatever we did in this equation, that Taylor series, you can see that it has some degree and what order. You can also see that if you have some equation like this, y equal to dy by dx, okay, minus dy by dx by 3, I think 1 by 3, okay, plus something like this, 1 by 5 dy by dx raised to the power 5, something like this. This is nothing but the Taylor expansion of ln x, okay? Then you can clearly write it like what, y equal to ln dy by dx. Now if someone asks what is the degree and order of this differential equation, then 1 1, answer is 1 1. Fine.
yes, sir.
Okay. Okay, so let's take some example of model problems. First example is exponential growth and decay, okay? Okay, this is one model problem. Suppose you have an equation like this, dy by dx is directly proportional to y, which means that suppose you have some radioactive element. If you have some radioactive element and the rate of disintegration of that radioactive element is actually directly proportional to the amount of radioactive element available, that model function is called exponential growth and decay problem, which means that you can see that if you have something like this, so you can see that this is nothing but the rate of disintegration, rate of disintegration. So you can see that the rate of disintegration is directly proportional to the amount of that element available. So you can see that this is nothing but exactly this is, okay? So, or if you remove this proportionality constant, you will arrive this kind of equation, okay? So if k is greater than 0, which means that if k is positive, then this kind of equation will be called what growth equation, okay? And If k is less than 0, this is called what? Decay equation. Okay, now let's try to solve this. Okay, you have differential equation like this. Okay, now move y here, you will get k dx. Okay, now integrate both sides, you will get ln y equal to kx plus c. Okay, now I can also write, let's move here, let's move this c here. I can also write minus c as another constant, suppose ln lambda. Okay, this is also a constant. Okay, or you can also assume ln y naught, ln y naught. I'm just replacing minus c is a constant, and at the place of minus c I'm writing ln y naught. So what will you write? Or you can also write, for I'm writing just minus ln, or you can also assume, I'm actually trying to get another form. Okay, so at the place of c I'm writing ln y naught, so that will be what? Ln y naught equal to kx. So this will be ln y divided by y naught equal to kx. Then this will be what? Y equal to y naught e raised to the power kx. So this is the solution. This is the solution of this differential equation. So you can see that you have one arbitrary constant. Okay, and here also you can see that this is actually known, because you already know what is the k. Here the constant is actually y naught only. Okay, because this is not constant, this is already. Okay, so here constant is this, that's why you are getting first order differential equation. Okay, now can someone tell me what will be the graph of this equation? Suppose in x-axis it is x and y-axis it is y. So you can clearly see that at x equal to 0, when x equal to 0, the value of y will be y naught. Okay, so this is y naught. Okay, now you can see that whether the graph will be like this or like this. Which one is correct? Tell me. Graph will be like this or graph will be like this? First one is correct or second one is correct?
First one.
First one. No. Both one are correct. The problem is it depends on the sign of k. Okay. The first one is correct if k is positive, and the second one is correct if k is negative. Okay, so this graph is actually called decay, and this is called what? Exponential growth. So it depends on whether what is the sign of k. Fine, so both are correct, right? Tell me.
Sir, here the y is not k is not constant, mean it is not arbitrary constant.
I mean, the thing is here k is constant, right? Because you already know. Suppose if someone asks, solve this differential equation minus 0.2 y, which means that you already know na what is k. I'm just solving for general k. If you have the value of k is minus 0.2, then it is sure that graph will be something like this. The thing is, you don't know why not, because this is actually integral constant which you are getting after integrating. This is actually arbitrary constant. Fine. Y
Yes, sir.
naught is actually arbitrary constant, not k. K you already know. You already know that what is the rate of disintegration, because the rate of disintegration is directly proportional to n. But what is the proportionality constant? You already know. Okay, you already know that what it should be, minus 0.2 or something like that. Okay, so yeah, so this is the solution. Now if someone asks, if if the half life, if the half life of, suppose that element is actually radioactive element. Okay, suppose the half life of radioactive active element is t one half. It will be represented as t one half, I mean half, is suppose 1250 years. Now you have boundary condition. If someone asks to find a equation of a radioactive decay such that its life half life is 1250 years. Okay, so here actually independent, here the independent variable is actually x will be replaced by t. So which means that that equation is actually can be written as n equal to n naught e raised to the power kt. This equation is nothing but in this form, because here I'm varying that function with respect to time t. So that's why instead of writing x, I will write t. Okay. Now suppose I have already k. No. Okay. Let's find this. It is saying the half life of radioactive element is actually 1250 years. Now what you will do is, it is saying that n will be become what, n naught by 2. Okay, n is actually n naught by 2, then n naught is same as that is initial constant. Okay, now I can write k and t equal to what, 1250 years. Okay, now you can see that this is nothing but minus ln 2 equal to, this is what, k into 1250 ln e. Is it correct or not? Tell me. Half life means the quantity when it becomes half. At what time? At t equal to 1250 years, which means that this n will become n naught by 2 at t equal to 1250 years. Okay, now you will get k. Okay, so k into 1250, what is ln e? Tell me, what is the value of ln e?
1.
1. Okay, now from here you can get k. Okay, I will use calculator. So you will get minus ln 2 divided by 1250. So you will get minus 5.545 into 10 raised to the power minus 4. Okay, what is the what is the unit of this k? What is the unit of k? Per year. Okay, so yeah, from this half life value you can also get k. Okay, so yeah, this is the solved problem. Okay. Okay.
Hello,
Now,
sir.
yeah,
How you
tell me.
write if I t from x?
What?
How you change x to t, sir?
I'm changing x into t because here x is the independent variable. Okay, and in the
Okay, sir. Okay,
radioactive
got it.
disintegration problem, that x is actually time. Okay, and y is actually the weight or the amount or the number of elements available. Okay, this is actually a general form. This is actually a general form, but now I am simplifying to the problem of radioactive disintegration. So x will be replaced by t and y will be replaced by capital N. So this thing can be written like this. Okay, so this is the same equation, just I am representing y as N and x as t. Fine? Tell me.
Yes, sir.
Yeah. Okay. Okay, so let's move to another model problem. Newton's law of cooling. Have you heard about it ever? Tell me. It says that
Heat transfer problems.
yeah, heat transfer problem.
Convection.
Hmm. So it says that the rate of change of temperature, will be actually directly proportional to the difference of temperature. The rate of change of temperature is actually the difference of temperature. And what is delta T? Delta T is nothing but this temperature at time t minus ambient temperature. So after removing proportionality constant, I can write dt by dt is k times t minus Ta. This is called what? Ambient temperature. Okay, so this is called what? Newton's law of cooling. So you can clearly see that this is also a kind of first order differential equation. It's very easy to solve it. How you will solve it? dt by t minus Ta equal to k dt, integrate it. Okay, so you will get ln t minus Ta. Here you have to understand that Ta you already know. And that is nothing but 298 Kelvin, room temperature, 25 degrees centigrade, which means that 298 Kelvin. So that will be KT plus another constant. Okay, now you have some initial boundary condition. An initial boundary condition is, suppose you have at t equal to 0, you have initial temperature. Initial temperature. Suppose you have earlier to 298. Suppose you have 300 Kelvin. Okay. Now substitute here. You will get ln 300 minus 298 equal to, at t equal to 0. Then you will get C. You will get C equal to ln 2. Okay. Now substitute here. So you will get ln t minus Ta equal to kt plus ln 2. Okay, so this will become t minus Ta divided by 2 equal to kt. You will get e raised to the power Ta. T equal to Ta plus 2 e raised to the power what? Kt. Okay, now this will become Ta. You already know what is Ta. Ta is 298 plus 2 e raised to the power kt. Okay, yeah. Now you have to understand what is K. First you want to know what is K. This is nothing but the material property. Material property, which means that this thing you already know, or if you want to know, then you have to get another constant, another boundary condition. Suppose if you want to get this, then you have to know that, like at t equal to suppose 10 seconds, and the temperature, that temperature has decreased. The thing is, or you can also see that at t equal to infinity, at t equal to infinity, that temperature becomes environment temperature or ambient temperature. Then on the basis of that, the value of k you will get it. Now substitute that, you have the variation of t. Fine or not? Tell me.
Yes, sir.
Any doubt?
So can you explain you again this slide?
This one,
Just go.
this one, last one.
So above side. Sir.
This one. Which line? What doubt do you have? Just tell me. Tell me. No doubt.
Okay, sir. Understood, sir.
Yeah, okay. Okay. So now we will understand what is the geometrical meaning of the differential equation. I will only talk about first order differential equation in this case. Then you will get to know. Okay. So suppose you have some kind of this differential equation, which means that y dash equal to what? Some kind of function. Suppose the same case, whatever I discussed, dy by dx equal to 0.2y, or I will take minus sign. Okay, now I will try to plot the solution of this equation. I will try to plot the solution of this differential equation. Then you can clearly see that at each value of y, you have the slope of that solution. So suppose now here you can create a grid. You can see that x can be everything. At the place of fxy, x can be any arbitrary number, but y you can vary it. So suppose I will create our horizontal lines, and that horizontal lines is nothing but to represent the value of y. Okay. So suppose this one is y equal to 1, this one is y equal to 2, this one is y equal to 3, this one is y equal to 4. Okay. Now you can see that when y equal to 1, when y equal to 1, then the slope of that curve is actually what? Minus 0.2. Okay. At y equal to 1, then you can see that y dash equal to minus 0.2, which means that the tangent line, the slope of the tangent line to the curve at y equal to 1 will be nothing but minus 0.2. So what will I do is I will create so many arcs, small arcs, and the slope of that arcs will be what? Minus 0.2. So you can see that at all x, when y equal to 1, the slope will be what? Minus 0.2. So I will, this is the negative slope, right? Yeah. So all these arcs are actually parallel to each other. Okay. Now when y equal to 2, y dash will become minus 0.4, which means that what? Slope the tangent will be more inclined towards the x axis. Are you getting what I'm trying to say? If at y equal to 1, if slope is like this, then at y equal to 2, slope will be like this, which means that angle from this direction has decreased. This is slope 0 minus 0.2. This is slope minus 0.4. So at y equal to 2, slope will be something like this. Okay, and at y equal to 3, slope will be what? Slope will be what? Tell me.
minus 0.6.
Minus 0.6. Okay, are you getting it or not? What I'm trying to say?
Yes, sir.
Actually, I think it is more steep. Yeah, it is more steep, no? Y equal to minus 0.4 means what? This angle should be more.
Yes, sir.
Yeah, this angle should be more. Okay, I will draw it again. I will draw it again. What will I do is I will create an axis. Okay. Yeah. Then I will create grid. Okay. Now I'm saying is when y equal to 1, slope is something like this. And all these lines, why I am creating for all x? Tell me, why I am creating this for all x? Tell me. Why I am creating these arcs for all x? Because here you can see that at y equal to 1, slope is minus 0.2 for all x, because you are not inputting any x. That's why slope will be minus 0.2 for all x. Okay. Now when y equal to 2, it will be more steep, more angle. So it will be something like this. And when y equal to very large, when y equal to very large, approximately infinity, then what will be the dy by dx? What will be the dy by dx? That will approach
Infinity.
minus infinity. That will approach minus infinity. That is nothing but a kind of vertical line, a kind of vertical tangent, when y will be very large. Okay, which means that the graph will be something when y is very large, not here only, when y is very large. Okay, so I cannot create a complete vertical line. I cannot create a complete vertical line. Okay, so it will be something like this. Okay, now what will I do is I will draw a curve from all y, then you will see that graph will be something like this. I am saying that the graph will be something like this, and this is nothing but the solution to the curve. This is nothing but the solution to the curve, which means that when y is increasing, then the tangent to the curve is actually, the slope of the tangent to the curve is actually increasing, but in opposite angle, with opposite angle. So this is the one solution. The thing is, there are family of solutions. This is not only one. There are family of solutions. You can connect any family of that arc and you will get the curve. And all those curves are actually solution. That's why it is called family of curves. But when you impose a boundary condition, when you impose a boundary condition like at t equal to half, the half life is 1250, then you will get some particular solution. And at t equal to 0, if someone says n is actually this, capital N is actually, or you can in this case suppose y is something like 12, then this is the boundary condition. Then this graph should start from this at t equal to 0, y equal to this. Then this solution will be called what? Particular solution. Otherwise, if you don't have the boundary condition, there will be family of solution. Are you getting it what I'm trying to say?
Yes, sir.
So this is called direction field. Direction field plot. This is called what? Direction field plot. So in this graph, whatever I drawn earlier, yeah, in this graph you can see that at each y there is a tangent line. And suppose you have some y, yeah, at y naught only, at y naught, which means that there is some tangent line. Okay, this is the tangent line. And when you calculate the slope of the tangent line at y equal to y naught, then in this case you will get what? Minus 0.2, and y equal to what? Y naught. So that will be minus 0.2 y naught at y equal to y naught. So the slope of this point, the slope of the tangent line at this point will be actually minus 0.2 y naught. So this is the thing you have to understand. It's fine or not?
Yes, sir.
Yes, sir.
Any doubt? Okay. So yeah, let's move to the